Venn diagrams and two-way tables. Do you remember the two-way tables where you had A, not A, B, not B as your things on there?
Yes.
What's the difference between a two-way table and an array?
What's an array?
Well, these ones down here are arrays. They're very similar. If you have a look down here at the array, we've got A, B, C, second selection of A, B, C. The only real difference between a two-way table and an array, a two-way table is when you are only having two possibilities on each of these axes here. And it's A and not A, B and not B. They're always the complements of each other on these axes here. Whereas an array can expand much more beyond just having two things on here. We can have as many as we like. The only restriction is that we can only compare two different quantities or two different things. So what I mean is we can only have two axes on that diagram. I can't roll a dice 3 times, for example, and put that in an array. That's going too far. We can only roll the dice once, roll the dice twice. Can't go to a third time. We'd have to go to a tree diagram if we wanted to do that. Okay, so another name for an array is a table. Tables are used to list the sample space for multiple events with 2 components. They can only have 2 components, one for each axis. If replacement is allowed, then the outcome for each selection can be repeated. So you'll need to pay special attention to the questions whether it says if something has been replaced or it has not been replaced. So for example, this diagram here with our A, B and C, so we've got 3 letters that we're selecting from. We choose a letter for our first selection, but then we replace it and we can choose the same letters again for the second selection. It means that we can have doubles. I can choose an A and an A, a B and a B and a C and a C because they've been replaced. However, if the question says that it was not replaced, if the A was selected in the first choice, then it cannot be selected for the second choice because it's already been chosen. And so we have these boxes that get crossed out because there is no option there for those. Okay, so with replacement and without replacement. So we have a couple of questions we're going to do. Example number 1, that's frozen. Oh, don't do that. Here we go. Okay, example number 1, we have a fair-sided dice that is rolled twice. So roll number 1, my possibilities are listed here. Roll number 2 across the top. The first thing we want to do, it says, is list the sample space in that table. Now be consistent when you put them in the table because sometimes the order that they occur in is important. So roll 1 has to go first. So it's going to be 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. Always putting the roll 1 first. Then the second column, 1, 2, 2, 2. And so on. Oops. All right, takes a little bit of writing, but we get all our outcomes written in there. Okay, then we have some questions to answer about that table. So part B says, how many outcomes are there? You can sit there and count up all those blue bits that I've counted in there, written in there, or you go 6 times 6 makes 36. Part C, find the probability of rolling a 1, then a 5. The way that is written means that the order is important, doesn't it? The 1 has to be first, then the 5. So 1, then 5 means it's that box there. Only one possible outcome out of 36. It is not, where's the other one? 5, 1. The order's wrong for that one, isn't it? Okay? So probability of a 1, then a 5 is 1 out of 36. Part D, find the probability of rolling a double. So that's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So there is 6 of those out of 36. Now I'm writing down, you don't have to write down this probability of a double part, but I'm just writing it down to show you that that's another way and type of notation that you can use to label what you're doing. Girls, stop talking. Part E, find the probability of rolling a sum of 7. These tables, if you write them in properly, have patterns in them. So this has a sum of 2. This one and this one have a sum of 3. These ones are sums of 4, sums of 5, sums of 6, sums of 7. They all work on diagonals. So sum of 7 is that one, that one, that one, that one, that one, and that one. Okay, do you see the diagonals I'm talking about? So that is 1, 2, 3, 4, 5, 6 outcomes again out of 36. So let's use our notation. Probability of a sum of 7 is 6 out of 36, which simplifies to 1/6. Part F, find the probability of rolling a sum of at least 9. Careful with the words. When I say at least 9, does that include 9?
Yeah.
Yes. So the sums of 9 would be 6 and 3, 5 and 4, 4 and 5, and 3 and 6. So they make 9. 10s, 11s, and 12. Okay, so how many of those are there? 1, 2, 3, 4, 10. Excellent. So let's go. Probability sum of at least 9 is 10 out of 36, which is 5 out of 18. Okay? So often it's the getting your table right to begin with that can be the trickier part for some people. Let's have a look at question 2. 2 letters are chosen from the word week without replacement. Okay, without replacement means once I have selected a letter, I cannot select it for the second time. Construct a table to list the sample space. So you can see the crosses have already been put in there for us. You would have to do that yourself, though. In most questions, it won't be done for you because it means that once I have chosen the W, I can't choose it again. It hasn't been replaced. Okay, and with the E's, this can be a little bit tricky. If I choose the first E, I can't choose the first E again, but I can choose the first E with the second E. Or, other way around, I can choose the second E with the first E. Okay, so I have the crosses in the diagonal. I need to fill in the rest of the sample space. This time, the way this is labelled is this letter is first, this letter is second. Okay, so they will change. They can change which one is first and second. This one, and when you make it, you can decide which one is which, but you have to be consistent when you fill it in. So E, actually I'll start with the first column. That would be W-E, W-E again, and W-K. Then E-W, E-E, and E-K. E-W, yeah, you should do, yes. As long as you've done it consistently the whole way through and don't start swapping. Okay, questions. Part B. Find the probability of obtaining the outcome W and then E. So W first, then E. There's one here. There's a few of them. There's one here, here. Any others? W-E, not E-W. Need the W first. So there is only 2 of them. So that's going to be equal to 2 out of how many outcomes? 12. Good. Don't count the crossed out ones. And that makes 1 out of 6. Next, we want the probability of selecting 2 E's. So that's that one and that one. So again, there's 2 of them. So 2 out of 12. Coincidentally, exactly the same answer. And last one, find the probability of selecting a W and an E. Is that saying that the order is important for that? No. So anywhere where there's a W and E, so it could be this one, W-E, W-E, or it could be E-W, E-W. So 4 out of 12, which is 1/3. Okay, so that's it. That's how we do our arrays or our tables.